Hello, and welcome to the second unit in Module 8 on participatory trial methodology, which we're producing as part of the live seeding project. So hopefully you completed Unit 8.1 on the beginning sort of background on participatory on-farm cultivar evaluation. In this unit, we're going to get a little bit more into the different designs that can be used for cultivar evaluation. So just to go through, remind you about the structure of this module. So we did 8.1 already about moving from traditional plot trials to frugal trial design. And this is unit 8.2 on the actual design. So we're going to introduce some of these designs that you might have had a quick look at in the last unit, but we'll go into a little more detail today. And these are those learning objectives that we're working towards in this module. I won't read through them all, but hopefully some of those words and some of the objectives are starting to become a little more clear to you, and you've started to achieve some of them. Today we're going to look particularly at decision trees and talk a little bit more about objectives, constraints, methods. So we're gradually building up that knowledge base to achieve these learning objectives. And the key resources, the same ones that I shared for the last unit, but just again to remind you about those coming out of the Live Seed project, and the links there that you can access if you download the actual PowerPoint of this video. Okay, so those links will then be active if you just open the PowerPoint and click through, and you should download those resources now if you didn't already do that. So yeah, what are we going to do today? How are we going to learn? A similar sort of structure to the last unit, a bit of a deep dive into the decision tree. So that will be a little sort of short lecture with me looking through those different decision trees that you find in the booklet. And then we'll have another video, and in this case, a few videos, not a webinar like the last unit, but actual short videos from Hungary from the Live Seed pilot. So quite a few of those, again, with some study questions to help you think about how those might relate to on-farm cultivar evaluation, frugal design, those sorts of topics that we're covering in this module. So applying frugal trial design principles. So first of all, as I said, refer to this useful booklet from Live Seed. So selecting the appropriate methodology for organic on-farm cultivar trials. It's got a lot of detail in it, and we're going to just go through some of the information in it today. But if you download that and have that handy, it's really a great useful reference for you. And it presents, well, at least 6 designs, at least 6. There's some sort of overlap among the designs, so you might say 7. But anyway, I'll show you a few of those today, and hopefully you'll become familiar with just using those decision trees to help you decide what the best design might be. And let's not forget our frugal trial design process and how we know that it's actually not linear as we presented it in the Live Seed project, but more of an iterative circular process where one might define objectives, identify constraints, apply a methodology, and then come back to that design process after applying that methodology for a length of time and maybe refine the objectives. Maybe some new constraints might have emerged, and the result will be adapting that methodology. So more of an iterative circular process as illustrated in that little diagram there. So who gets to define the objectives, and what sort of objectives might they be? So this is where we get into this area of what we call sometimes co-design. Here we're calling it co-constructing the project, where we might get together with a group of stakeholders or actors. Sometimes we use that term. People that have an interest in the product, in the value chain, and not just the farmers. In the case of cultivar evaluation, that's not just the farmers, but people all the way along the value chain. So we can imagine some sort of a collaborative, open dialogue in a workshop setting like shown in this picture, where together you would brainstorm and work on objectives. You might do some sort of SWOT analysis of the current situation, try and really home in on what are the barriers to identifying the best cultivars, and what are sort of some of the outcomes you might want from a trial involving cultivar trials. So it could be something as simple as determining the highest yielding variety on my farm, if the actor making that statement is actually the farmer or the producer, and that's absolutely fine to have some individual specific objectives coming from the farmers in the room or bakers if it was about quality. But there also might be broader objectives like to identify a variety suited to organic bread wheat production in a region, right? So that's slightly different than what's the best variety or the highest yielding variety on a specific farm. So that might affect the design of the trial. To identify a variety resistant to an emerging disease challenge in the region. Sorry, again, my video is blocking that. I haven't quite figured out how to hide myself. I keep showing up on every slide. But yeah, it might be actually not about yield. It might be about diseases. It might be quite a sort of very immediate challenge like this one, a sudden, in the last year or two, new fungal disease that's emerged and a need for a rapid response from the group of producers, identifying a better variety. So it's all about co-creating, co-identifying those objectives together. And there can, of course, be more than one. And then what are some constraints? That's something else that's important to identify and that you might do in that same sort of a meeting. After you've defined objectives, you might think about, wait a minute, where are we going to get the seeds from? Do we have access to all of these varieties we'd like to trial? How many do we want to test? What are our capabilities for running trials on farms? So how much labor and equipment is this going to take? Who's going to provide it? And we shouldn't make any assumptions here, even on something like labor and equipment. It might be that we don't expect the farmers themselves to provide it. It might be that the group agrees on some sort of a model where there's an external contractor involved, an external partner who has expertise in setting up trials, right? So on farm doesn't necessarily mean farmers are doing all the work at all, but we know there's trade-offs in costs of trials, right? So it's just something to consider and really not sort of overlook at this design stage. Again, practical numbers of plots. I mean, researchers, if you work with them, will always want multiple plots, multiple replications where, it's the same variety again and again, right? Because it improves statistical rigor, but what's really practical for the farm? Again, how big should the plots be? Again, scientists, researchers may be used to very small plots that are suited to small experimental equipment, but if it's a farmer sort of trial where the farmers are doing the actual establishing of the trial and managing the trial and harvesting the trial, then size is really important. What is the size of the drill on each farm? It might not be the same on every farm. What combine or harvesting equipment's available? How many locations, how many years, all of those different things. So others you could probably think of as well, right? These are constraints that it's really important as a group to define them because it will really help determine what is the best trial design, right? And what's going to really work to answer those questions or objectives. And objectives really can be framed as questions. So sometimes we call those research questions. There may be constraint linked to data. So again, farmers and researchers might want to collect data on everything. They might think it's really interesting to, look at weed populations and, ecosystem service delivery and all these sorts of, types of data like I've listed here. Phenotyping, morphology, phenology is one that we sometimes refer to. Phenology being here, you can see here, being the timing of when the varieties reach certain growth stages. It's not maybe always relevant to the objectives. So what are the most relevant types of data to address the objectives? How can we kind of put some boundaries around the data that we collect? What type of measurements will be possible? So again, skills of the team, equipment, time, money. What else? Tools available. And in Module 10, we're going to talk more about some of the really cool new apps that are available to help you design trials and also collect data. So hopefully, good to include at this early stage people that know about those tools or used to look ahead to that module, Module 10, as I said, in this project, to just think about in advance, what tools might you use in your trial? What would be most suited? And do we have the expertise to evaluate and interpret the data? And important really to recognize that when maybe some outside expertise needs to be called in, because we're not all experts in everything. So, you know, the farmer participants might be able to set up the trial and do a lot of the monitoring and measuring. But when it comes to actually doing some kind of robust analysis on the data, might need to call in someone to do some statistics. So more on this stuff around the data, types of data, how to analyze it in Module 9. And as I said, Module 10, a little bit more on the tools coming that way. So let's look at these decision trees to help us design on-farm cultivar evaluation trials. So as I said, they come from this particular booklet, selecting the appropriate methodology for organic on-farm cultivar trials. And in that booklet, if you have a look at it, you'll see there's basically 2 decision trees. So the first decision tree, and I guess I should just remind you what we mean even by a decision tree. We just throw that term around without maybe defining it so clearly. You might think of it almost like a flow chart as another type of word. It's basically a tool that you can use on paper to help you make a decision based on just answering a series of questions about your given situation. In this case, the situation being an on-farm cultivar evaluation network. Right? So there's one of the trees is all about if you're setting up a network to compare several varieties at the farm level within a network of farms. And there's quite a gray area actually between these 2 decision trees, as you will see. But if the primary purpose is about that first objective I had on an earlier slide, you know, what's the best variety on my farm? Local adaptation at farm scale of varieties. So if the primary objectives are really sort of farm level objectives, then this is the decision tree that you would follow. So it's appropriate for farmers involved in participatory plant breeding or assessing varieties. And in this module, you know, we're talking more about that, not the actual participatory breeding, but the actual assessment of varieties. But it also, if a farmer's involved in breeding, also it would be appropriate. Oops, my mouse is. Also, and then the second decision tree, this one is about comparing several cultivars at network level. So slightly different objectives for this decision tree. And it's really more about broader scale assessment. So making sort of running cultivar evaluation trials in order to come out with some conclusions and recommendations that are applicable at a broader scale. So sort of regional, or what we call pedoclimatic zone, meaning a pedoclimatic zone is kind of an area that's got similar soils and climate, right? So much bigger scale than farm level. And so, you know, you might the outcomes of these 2 sort of levels of network trials may not be quite the same. You know, the primary objectives not quite the same, where the first tree, as I said, is about those farm level objectives and meeting the needs primarily of the individual farmers. The second one is more sort of broader scale, being able to make some broader recommendations, more general recommendations. So the second one is more appropriate for stakeholders. It could be farmers, but network facilitators, seed companies, cooperatives, let's say, who want to make recommendations to their members in a given region. Could also be people along the value chain, right? Like processors, you know, if we're talking wheat, which we so often are in these projects, you know, it could be linked to bakers, millers and bakers, right? So broader adaptation, but there's quite a lot of overlap you'll see when you look at these trees. And they actually show what 7, I'm calling them roots through the trees. Roots, not roots like tree roots, but roots like a way to get somewhere. A road maybe, road map through the trees are shown. So we'll focus on those most relevant to participatory on-farm cultivar evaluation. So let's look at a few of these so you can become familiar with them. So I've called this one Design Route 1, and if you were looking at the booklet, you would see that this is on the left of the decision tree on that page that's for farm level design. And again, sorry that my face is obscuring some of this, but I think most of it we can see. So it's and you basically, with these decision trees, you sort of start at the top. You can see the arrow from number 1 going down, and you follow the route through based on your answers to questions. So for instance, at least 20 locations. So I've shown you this first one, which is the one where these are sort of the answers to the questions. So number of locations, at least or a minimum 20, and many varieties. You can see in very small print there, many varieties. So quite a lot of locations, many varieties. So this is getting into the actual design, and it's quite interesting. Some designs require what we call a common control. And what that is the same variety grown at every location. Okay, and that's called a common control, and that's sometimes used to better understand what is that underlying variation among the locations. So you've got the same variety, you expect it, well, not to perform the same. It performs differently, but you expect that will be because of something about the inherent characteristics of the site where it's being grown. So sometimes we have used statistical methods where we have that what we call common control, and that's used in the calculations to better understand how many of the differences at a site are due to true varietal differences versus site differences. Anyway, the point with this one is that this doesn't use that. This does not use a common control. What it does instead, which is quite novel, is to have one variety replicated at each location. So what that means is that one of those varieties, but not the same one at every location, but one at every location, is grown twice. And that's going to be used to give an indication of in that site how much within site variation there is. Okay, so we get into quite advanced statistics if you go down the tree, and we're not in this module really getting into the nitty-gritty of statistical analysis, but just trust that in this particular route, that's the way it's done, that you don't need that common control, but you do need a replicate of one variety at each location. And this is kind of all explained here, where it says 2 varieties or more per location. So at least 2, but probably quite a lot more. Suitable to evaluate lots of varieties, and this is where it says no need to share the same control, but the farmer chooses the varieties on. Oh, and this is where I have a little arrow here. I've just noticed that, because of course that should be on their farm, because a farmer might not be a man. Just a little point I noticed there. Number of varieties can vary, more varieties better, etc. And then this one here, one variety replicated within the location. So. And then it goes on to explain more details about it. It can include regional farms, which, as it says there, receives several varieties in 2 or more blocks. So though they actually do have a bit of what we call a replicated design on the regional farms, but the satellite farms not. So it could include both or not. And then the data. Now we're going to talk more about data in the next module 9, but just so I'll explain more there what we really mean by scores and quantitative traits. But for now, just maybe remember that scores, quantitative traits, there's a little bit there to explain it. Sorry, my head obscuring it, but scores are more like, 1, 2, 3, 4, 5, a bit more subjective scoring, as opposed to quantitative measured traits, which are actually actual numbers. Now, the interesting thing is this sort of design can also be used for network level assessment. So if you looked closely at the other decision tree, you would see that this precisely the same design is also included in the network level. So it's actually can be used for both, quite a versatile design. And this is some of the pros and cons. So this is showing getting a little bit more into the types of outcomes. So you can see you'll get results that show you the different varieties. Now this is too small to read right now. I've made a note that I'm going to update that in the next version of this lecture to give you a bit of a better image. But it basically, statistics are done to indicate which varieties are genuinely different from each other. So proper statistical analysis to identify statistically significant differences or not. Talking here about some of the pros and cons. First of all, staff, they don't really say pros or cons, but just stating that the setup is probably fairly easy for the farmer. If the farmer is provided with a plan, they can follow it. There's normally we in the UK do this sort of thing with strips of wheat in fields, so fairly straightforward to set up, not too complicated. And they might be able to take the measurements as well. But also you might want researchers, technicians to go out and take them. So the pros are listed there. That's some of the benefits. Fairly simple. Lots of varieties can be evaluated, few seeds, etc. And then some stuff here on the software. R is a very well-known statistical package that's open source, freely available, that most sort of researchers, graduate students, PhD students, research associates are familiar with, and they can sort of download the right what we call packages to analyze the data. Cons, quantitative variables may be difficult to measure accurately. Right, so that's where you really need, if you do have sort of this distributed model of farmers collecting the data themselves, which is great, then it has to be really clear how those things are measured. You know, things like disease assessments. There's many different ways to assess the level of disease damage on leaves. You know, which leaf do you look at? Do you assess, you know, how many leaves do you assess? Are you just looking at percentage on the individual leaf, or are you looking at percentage in that area? There's a lot of different ways to do these assessments, so it's just really important that the standard protocols are developed and distributed. Routes 2 and 3, these really, to me, as a person who spent a lot of my career working in agronomic trials on research stations, these look very similar to what you would see in an on-station trial. Not so much what you would see in on-farm trials, unless they're just essentially using a farm like a research station, which sometimes is appropriate if you want one of these more complicated replicated trials conducted under organic conditions. But it could suit organic networks if variety choices and growing conditions are decided collaboratively. So it could still be a participatory trial conducted on a research station or on a farm that's sort of acting like a research station. But you can see that they're more complicated. You've got things like fully replicated block designs, and what this other one on the right that's called a row column design, and sort of fairly typical standard analyses, classic analysis of variance. That's what ANOVA is, and then some other models that are hidden by my head there, but a little more complex statistical models as well. So this is really, like I said, looking much more like what you might see on a research station, requiring technicians to help. Farmers or technicians could collect the data, but you definitely need someone with some experience and expertise in the statistical side of this one. Now let's look at these network level decision trees, which are, as I said, for slightly different objectives, more about making more general conclusions that might be applicable at sort of regional scales, not necessarily farm specific. So for very large scale participatory trials. And here you can see again numbers of locations. We're talking many locations, right? So here we have 100 locations or more, so very large trials and few varieties. And this is quite an interesting option here. We have these what are called triadic designs, or sometimes trico designs. Okay, so this is really quite novel and much more of a participatory citizen science approach that you can do some Googling around on and find out more about. But in these sorts of trials, not very many varieties on a given farm. And the whole statistical approach is about ranking varieties. So that's not the same as scoring or measuring something quantitative. It's about putting the varieties in order. So it's about just looking at them and saying, this one was better than this one worse than this one, and just sort of asking the farmers to put them in order, to rank them. And that's sort of just explained a little bit more in the documentation. And you can see here, it says here, rank. In this section, measures rank. Each farmer indicates for the 3 varieties evaluated on his, oh, there he is again, there he is again, evaluated on their farm, the best variety and the worst variety. So what's the top? What was the bottom? For a given trait. Now there could be a lot of different traits. So this isn't just yield, but could be all kinds of whatever the farmers and the network agrees are the important characteristics or traits of the varieties that they want to better assess. Up here you've got a little more on the triadic design. Again, no need to share the same control, so that's useful. 3 varieties or more at each location. Suitable if there's not too many varieties to evaluate. That's right, because you can see in this one it's heavy on numbers of locations, but probably better to have fewer varieties. The farmer cannot choose the varieties though, so they are like dictated which ones they have on their farms, but presumably they're ones that most of them are interested in. So yeah, it's known as TRICO or triadic design. Really quite intriguing. Here's a little more detail on TRICO, and I went to our friend ChatGPT for this one. I just typed it in to see also what it would pull up on TRICO or triadic trials. And you can see there, TRICO stands for Triadic Comparison of Technologies, which I didn't know until I asked ChatGPT. Yeah, very much a citizen science approach. So, you know, participatory, the citizens in this case being the farmers, are out there collecting this ranking data. And it just explains, again, 3 different treatments. And of course, not necessarily varieties, right? It could be other sorts of technologies, innovations that people are interested in testing on farms. So it could be, you know, fertilizer types, could be, you know, pest control, whatever the innovations are that the participants want to trial. But again, just stating there, ranking, the important thing. And then the statement here, this comes from ChatGPT, it reduces the cognitive and logistical burden. So ranking 3 options is easier than evaluating more, for sure. Just look at those 3, put them in order, report back in some way. Very, very decentralized. And I've just made a note, yeah, the farmers could grow more than 3, but they only rank 3. So I guess that's for if their own interest, they have in their own interest, they want to look at more, and they want to see where other ones might fit relative to the 3 that they're ranking, then they could do that. But 3 sort of are needed for the analysis. And you can go to that website, again, that'll be linked through on the PowerPoint that you should have downloaded alongside this recording of the PowerPoint. And you'll go to a website there which has lots more resources on these TRICO or triadic trials. And this is an example actually from one of them. And this is a Nicaraguan bean trial. This example is also elaborated in the deliverable I mentioned, D2.3, Ray et al. 2021, so you can have a look at that. So this is a Nicaraguan trial in Nicaragua, 10 varieties. You can see 842 plots, so that was a heck of a lot of plots, grown on farmers' fields between 2012 and 2016. And I'm sorry, again, my head's obscuring that, but there was actually an academic publication produced on this trial, Turner et al. 2020, and again in the PowerPoint you should be able to see the full reference for that. And there, just a quote from that paper, again it says, each farmer ranks the performance of 3 varieties randomly assigned from a larger set of around 10, and plus a local variety, and that's a TRICO trial, sown with a locally known variety, yeah. So, and in this particular trial, 6 to 8 traits were scored, agronomic yield, etc. You can see. And overall performance, which is really interesting with the farmer plant this again. So that diagram on the right is what was shown in the paper, which is a little bit, maybe a little bit difficult to interpret, but it basically, the statistics resulted in these 11 varieties. So you can see along the bottom, 1, 2, 3, 4, 5, 6, up to 11, right? So that's the 10 plus the local makes 11. And the data, all those 842 data points, and if you sum up 306, the N, 489 and 47, you get 842. So that's reassuring. I did that just to check. So that's all the data points basically when the analysis was done, and they also included these environmental variables. So one of them was the maximum temperature overnight during vegetative growth, right? And then these are the actual sort of physical locations, just codes for them, which are described in the caption, PR, PO, AP, they're different codes. But basically, the analysis divided up the data in this way, these showing that, for instance, the highest yields were obtained at this location, PR16, when if you follow along here, when maximum temperatures at night were less than 18.7, which is quite interesting actually. So cooler temperatures at nighttime. And this is where you got the best yields from this particular variety, 7. 7 didn't do so well. You can see at these other locations, and so at the other locations, number 9 seemed to be the best. You can see it here in the other locations again with temperatures below that. If you happen to be in a hot location, you might want to choose a different variety. My head's obscuring, but it looks like it's this variety here, the 4th one in. So variety number 7, 1, 2, 3, 4, no, 8. Sorry, variety number 8 was the best at that location, whereas here, variety 8, not quite the best. So it's quite an interesting way of using citizen science approach to generate lots of data and come up with some useful outcomes in terms of ranking what's best, what's not so good, and then also explaining the conditions where it might be best or not. So really interesting. Yeah, so it just identifies the best variety depending on those things. And here's some pros and cons. And you can see there an image from a place in Nigeria, the IITA, International Institute of Tropical Agriculture, using these approaches a lot with farmers in Africa. So setup of experiments, they're pretty easy to set up by the farmer. You could imagine that if a farmer had been involved in one in the past, they'd pretty quickly get quite skilled and understand what they needed to do for a triadic trial on varieties or practices. And taking the measures, the ranking bit also quite straightforward. It says here ranking data taken by farmers, pedoclimatic data managed by the facilitator. So simple design, easy protocol, and there's software. This is called Placket Loose. Again, we're not going to get into R analysis in this module, but those of you that know about R, there is again a package in R for this sort of design. So really, I think really kind of interesting participatory way to answer some questions for groups of farmers. Needs a lot of seeds, that's one of the drawbacks, and not so many varieties being evaluated. And of course, many locations, as I said, need over 100 locations. So, but really quite novel, I think. And then finally, this is sort of, again, system level design, looking very similar really to the more on-station based approaches I showed you for farm level design as well. Little more complicated, incomplete block designs, fully replicated block design using quantitative measures. So these are, nothing like sort of the participatory TRICO design I just showed you. These are much more of your standard traditional approach to assessing varieties, usually done on research stations, but could be done on a farm. So you can see here, much smaller numbers of locations required, could be as few as 2, but many varieties could be analyzed in an incomplete block design, fewer varieties in a fully replicated block. So again, not to say it's not an on-farm cultivar evaluation approach, can be done on farms, especially, as I said, if it's important to do those evaluations in the background of an established organic management system using organic practices, but probably requires more expertise and resources to set up, difficult for a farmer to set up on their own, and it's just, yeah, that's mentioned here, maybe difficult to establish if many varieties are evaluated. So pros and cons to that, but something that I think we're probably more familiar with than some of the other designs I've just shown you. So that's all of the different decision tree design options I wanted to show you, but they're in that booklet and you can have a look and a read more up on them in the booklet. So now we're going to have a look at some Hungarian case studies. So there's 4 videos to have a look at, and they're about a lot of different aspects of developing markets for ancient grains and cereals in Hungary. Part of that is cultivar evaluation, but there's a lot more than that in these videos. So it's just a chance to have a bit of a look at a sort of an integrated program that looked in many ways at organic variety testing, how it was done, how the value chain was involved, and just how participatory it was, etc. So there's again, as there was for the last unit, a list of some questions and answers for you to have a think about and follow through as you watch these 4 videos. And it's 4 videos, don't worry, they're not super long. I think altogether there's only about 20 minutes of video there. So you have a look at those, give them some thought, write some answers down on the question sheet, and then if we were in person in real time, we'd then follow on with discussion. If you're doing this self-directed on your own, just kind of reflect, and you can have a look at the PowerPoint alongside your questions after, and just sort of reflect on those questions a bit more. And then there is a sort of answer sheet, again, as I said in the last unit. There's not really right or wrong answers, but just a few points of what I pulled out of those videos as I watched them that might be relevant to the questions. So have a look at those.